Bismillahirrahmanirrahim. Reflection of sound. Reflection of sound. The bouncing back of sound when it strikes. When it strikes a hard surface is called reflection of sound. The bouncing back of sound when it strikes a hard surface. When it strikes a hard surface is called reflection of sound. Let's say these are called incident waves, sound waves, and these are called reflected sound waves. Reflected sound waves. The bouncing back, the bouncing of this sound, the bouncing back of this sound from hard surface when it strike a hard surface is called a reflection of sound. Just like light, sound can also be made to change its direction and bounce back as shown in this figure and shown in the figure. The reflection of sound, however, does not require a smooth and shining surface like that of a mirror, 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 but can reflect it from any hard surface, just like wall, just like metal sheets, just like wall, metal sheets, plywood, etc. Plywood, etc. Now, some practical application of sound. Practical application of sound waves. Some practical application of sound waves are: number one, echo. Number one is echo. Echo, the phenomena due to which the repetition of sound is heard after reflection from a distant object, such as a high building or a rocks after the original sound from a given source dies up is called echo. Or the repetition of sound by reflection of sound waves, from a surface is called an echo. It is therefore necessary for echo to be here that the time between the production of sound and hearing of its is equal to or more than 1 over 10 second. T is equal to 1 over 10 second, equal to or more than 1 over 10 of second, or equal to 0.1 second, 0.1 second. The minimum distance between the source of the sound and the reflected reflected body sound be 17 meter. That is, if the time hearing is t is equal to 1 over 10 second is equal to 0.1 second, and v is equal to speed of sound is equal to 340 meter per second, 340 meter per second, then d is equal to v into t divided by 2, because the waves are incident and then reflected. So s d. So 2d is equal to v into t, or this implies that d is equal to v into t divided by 2. Now putting values, so 340 multiplied by 0.1 divided by 2. So this is equal to 17 meter. 17 meter. Thus 17 meter is the minimum distance required for hearing an echo.